The session about Python, you're in the right room. If not, you should leave. We're going to start pretty soon. Just give you some time to type in the address that's on the screen so you can follow the presentation with me. This is going to be intense, guys. Get ready. Sorry about the address. Is that Google generated that? It's not the ideal, but it's 0 and lowercase l, not I. Have you guys found the presentation? Yes? Don't go ahead. There's spoilers ahead, okay? All right. So welcome. Welcome to the Advanced Cleaning with Python. I know the original name of this session is Joining Multiple Excel Files with Python, and that's exactly what we're doing, but we're also teaching you some advanced cleaning techniques with Python, and we hope you enjoy it. My name is Marco. I'm from School of Data, and also from J++ São Paulo. This is Annelise. She's from J++, Paris and Berlin. She'll be helping out with the session as well. So if you have any doubts, just raise your hand and Annelise can go to you and help you, okay? So what can you expect from this session today? We're gonna be using Python 2.7. We will be learn by doing. So don't focus on the specific example of this session. Focus on the approach. We're going to be using CSV and XLS files, so Excel files. I assume you guys know already what is this. We're not going to be covering the definitions of those formats. We're going to be using regular expressions. So if you don't know what regular expression is, have faith. You will try to learn today. We're going to be using Python modules and libraries. If you have been using Python, you probably know what Python modules and libraries are. And we also are going to be using computer algorithms. You know, assign values to variables, create if and else statements, control flows, etc. And we'll be seeing cool tricks, so stay with us. What is this session good for? So some people might be asking, why would I be learning advanced cleaning techniques with Python? What is this good for? This session is good for situations where a government agency publishes a report every month, for example, on their website with updated information, and every report is a different file, which is the case for the session today. But could also be the case of a company that publishes quarterly reports about financial status. So you have different files that preserve some of the structure, and you need that information on a single file. Or any situation really where there are a number of files that preserve the same structure between themselves, and you want to consolidate all the data together in a single CSV file for further analysis. So to get ready, please go to this address. It's a GitHub repository. If you have the presentation with you, you can just click on the link, download the zip file. I'm going to show you how to do this. You decompress the zip file anywhere, and you run terminal on that location. We will be using terminal, people. Don't worry. It's gonna be good. Okay, I can go back to the presentation address. This is the presentation address. It's a lowercase l, not an I, and it's a 0, not an O. It's the worst name for a short URL, but it's what we have for today. Okay? Yeah? And also thank you for translating in real time what we're talking here. Thank you so much. All right. So if you found the GitHub, you will be seeing a screen like this, okay? Like this. And what I need you to do is to go to the download zip here. Click there, download the zip file to your computer, and decompress anywhere. And then you have a folder like this. That will show these files here. Cleaner.py, data, license, readme.md, and then a folder called step by step. Are we good? Have you guys downloaded the file? No? Just click here on the download zip. And then you decompress anywhere. If you couldn't download the file, just raise your hand and Annelise will be able to help you.
Maybe you want to show the Google address again.
The Google address again? This one?
Yes.
The one for the presentation? Yep. It's a 0. No pain, no gain, right? And it's capital K or lowercase s. All right. Okay, cool. So if you've done that, don't worry about the steps. On the GitHub page, there is a tutorial, a massive tutorial that you will have lots of fun going through. So this is the tutorial, right? It has all the steps and everything that you need for this session. So don't worry if you miss anything. You can always go back to this tutorial and retrace the steps, all right? But for now, let's focus here on the presentation. Let's take a look at the problem. We will be trying to get information from multiple files and get that information in one single file for further analysis. And to do that, we need to have an approach. We have to have a cleaning strategy. But what is the data that we'll be working with today? The data that I selected is Medicaid managed care enrollment reports from the New York State in the United States. This data can be used as a way to determine which company would make a good subject based on its growth size. And you can see the source of the data here. This session was based on Sarah Cohen's, a New York Times journalist, panel that she gave at NICAR this year. NICAR is a data journalism conference that happens every year in the United States. And she held an advanced data cleaning session with OpenRefine. I translated those concepts to Python, and I used it based on a script that I made for J++ São Paulo. If you want to see the source, you just click on the link, and this is the page where the files are. So you can see there are Excel files for every month, and it's a nightmare. You have to download all of these files either using a script or by hand, and you have to go into every file. It's a nightmare to consolidate all the data. That's why we're using Python today. All right. So this is when you open the Excel files, this is what they look like. So you have the name of the file up at the top. You have the date in one of the cells. You have the name of the counties inside New York State. You have the plan name. This is the name of the company that has enrollments in Medicaid. And you have the total number of people that were enrolled in different categories. And it doesn't matter to us today to fully understand this table, just that we need the number of enrollments to see how the companies are growing. But the way it is here right now, we cannot really analyze how the companies are growing because we have multiple data formats on the same columns. So if you look at the county column, it's a group cell here. So we have the name of the county, but we also have some text here that describes when it was mandatory in that county to have Medicaid. The plan names, we have a cell that has the totals value. It's not really a plan name. So this table here may be useful for human inspection, but it's not really useful for data analysis. And that's why we need to extract specific information from the cells to generate the CSV file that's going to be useful for us. And taking a look at the columns, so we have the name of the columns here, and we have the values here. And in the end, we want something like this, right? So we want the total, the name of the columns here, the month, the county, the year, the plan name, so on and so forth. So this is more useful for us to make analysis. This is useless. And you can see there are multiple files. So this one specifically is for January 2013, the first file of our series. But there are multiple files, and all of this data is separated. So we need to find a way to get them together. Before we get into coding, we have to design a cleaning strategy. And this is the important bit of this session today. It's not really about learning the Python part, but thinking about the strategy that you're going to use for cleaning on any file, right? On any situation where you might want to do that. The first thing you have to do is to envision success. Then envision success. See what success looks like in a situation like this. Think about columns. What are the columns that you want to have in the end? Look at the dirty file, the human report, and think about the columns that file will generate for you in the end. Just like we did here. So these are the columns that we're looking for. Think about the columns. Look for patterns and repetitions. And what would you do if you were the cursor that highlights the cell? And I'm gonna explain this real quickly. These are our columns. So year, month, county, plan name, ADC, SNA, SSI, NI, SOH, and total enrolled. The names of the columns are arbitrary. You select the name of the columns. And you always have to look for patterns. So let me open the file here really quickly and show you what I'm talking about. Is it still visible? Yeah, can you see the file? Okay. So this is the same file that we were seeing. Take a look at the first cell. This is A1, right? If we were the cursor and move the cursor around to highlight stuff, we can find the positions of the information that we want. The first information that we want is on cell A4, which is the date. And the value of this cell, it's down here, it's NYS, January 2013. So in every file, and you can do that, but I already did it for you. In every file, the information about the month and the year is in the same position. A4. And this is an important information. This is a pattern and a repetition that we need to look for. Also, the name of the counties and the name of the plans are always in the same first two columns. So in these two columns here, it's always that way. The other thing that is a repetition in a pattern is that the name of the county is always one cell to the left of these totals. Can you see the totals here? It's written totals, and then the name of the county is always one cell to the left. So if you go to the next county, it's one cell to the left. One cell to the left. And this is important because we're going to ask our robot, our Python robot, to look for the totals and get the cell exactly to the left in every file. And then we will get the county name of that. Another thing that is a repetition that we should be mindful is that the plan name column ends when there is an empty space. So on the second column, when our robot finds an empty space, it means that we have selected all of the counties. So these are the patterns that we're looking for in a file when we need to clean it and extract the information. We just need to make those extractions automatically. And I'm going to show you how to do that. So this slide here is a summary of all of the repetitions and patterns that we're looking for. So the information we need is always in the first sheet of the Excel file. This is something that I forgot to mention. If you look here, this Excel file has multiple sheets, and the information that we want is always in the first sheet, right? Dates are always in the same cell, which is A4. Name of counties and plans are always in the same columns, A and B. The list of plan names always start with the string totals. The county name is always immediately one cell to the left of totals. The list of plan names always end in an empty space. After that, we have data for the New York City, which we won't capture in this exercise. So let's get into the code. Please go into the step-by-step folder, and we're going to go file by file, step by step, building this strategy, okay? Just open the step-by-step folder here and open up the first file, which is 01 cellvalues.py. And this is the file.
Excuse me.
Yes?
What program do you open it?
Okay, so I'm using an application called Atom. It's a code editor, but there are a number of code editors out there. Atom is just one of them. There is TextMate, there is VI, there is Nano, there are a number of applications. There is Sublime Text, there is Data Wrangler. It's every person has its own taste. I'm not advocating for Atom. You should use whatever you want. But usually it's good to use a code editor because they highlight the syntax, and it's really nice to see what you're doing. It's not like a regular text editor. It has a bunch of features that speeds up and facilitates the coding process. I'm just going to get rid of this here. Okay. Can you guys see the code? Yeah? We're going to start looking at the code. Are you ready? You have to be ready. We're going to do this. Okay, so the first line of this file imports a module called XLRD. XLRD is a module that opens Excel files within the Python framework. And to have that module on your computer, you need to do the following. You need to open your terminal, if you have Python, and then you do pip install xlrd. That's it. After you do that, you will be able to import the module into your Python applications. So just do a pip install xlrd. Unfortunately, you cannot run this code on online terminal or consoles because you need to install this library, and you can only install this library in a machine that you have control. So pip install xlrd. Okay. So this first line here shows you that we are importing one specific class from the xlrd module. This class is Open Workbook. There are other classes, but that's the only class that we need. Open Workbook will give us the tools that we need to capture the cell values, the column values, and slices of the Excel file that we need. So really simple. We are going to open a workbook with this file, and we're going to use a function called sheet by index, which opens the first sheet of the Excel file. Like I showed you, the information that we need is on the first sheet. And this function right here imports the first sheet. And then we print the value of the cell using the function cell value of the Open Workbook class right here on line 7. The cell value function uses the opposite logic that we are used to when we're talking about spreadsheets. Usually we do A4, B4, those are the coordinates, right? We talk about the columns first and then the row. But this function here is the opposite. First we declare the number of the row and then the number of the column. And usually in computer programming, you start the count at 0. So actually row 3 for us humans is actually row 4. And column 0 is actually column 1. So this is the cell A4. This is exactly the cell that we are importing. So going to the terminal, I'm going to execute this script and see what happens. I'm going to run Python 01, and I'm pressing tab to do autocomplete, and I'm going to run it. And see, if you see here, it's exactly the value of the date. So if we go back to the document, Python is capturing this value. So it opens up the spreadsheet, opens the first sheet of the file, and then extracts the information from cell A4, which is row 4, column 0, column 1. Okay? Very simple. This is the first thing that we do. All right. Open up the second file, 02 column values.py. This second file is very similar to the first one. In the first one, we extracted one value from one cell. This second file, we are extracting the values from a column. So instead of just getting one value from one cell, we are listing the values of a column, all of the values. And to do that, we have the same approach. We import the class Open Workbook from xlrd. We assign the object on the first index of the sheet to a variable called sheet. And then we're going to iterate over the column values. So the function to call the values is call underscore values. And then we do the number of the column that we have. 0 is the first one, 1 is the second. So this gives a list of the values on the second column, which is this column right here, this one, column B. which is basically the names of the plans, right? The names of the companies. So we are listing the names, the values on this column, and we are iterating over these values. And we are printing to the terminal the values of these cells. Okay, so this script number 2 basically just prints out the values of column 2. Let's see how it looks like. So I'm going to do Python 02 tab on the terminal, and I'm going to press enter. And here we have all of the values of that second column being printed out. Because we have empty cells at the beginning of the spreadsheet, you can see here, empty cell here, empty cell here. Those are all empty cells. The first cell to have a value is cell number 6. That's why we have this big space here. But we have all of the plans names here, okay? All the way to the end. And true enough, see that there is a space here. This space is the indication that our column ended, and we're going to use this in the end. All right, so we extracted cell values. We extracted column values. Let's take a look on how to get row values, right? We get one cell, one column. Now let's get one complete row. So open up file number 3, row values. And it's right here. And the approach is very similar. We import the open workbook. We assign the sheet variable with the object. And we're going to use a new function called row slice, which is slice of the row. And this function gets 3 parameters. The first one is the number of the row. The second one is where you want the slice to start, in which column. And the third parameter is when you want it to end. So in this case here, what I'm proposing, what I'm suggesting is we are going to get on row 4, which is actually 5 because it starts on 0. So 0, 1, 2, 3, 4. So in row 5, I want the extraction to start on column 0, 1, 2, which is the third. And it's going to end on 2, 3, 4, 5, 7, before the 7. So what I'm basically doing is getting the names of the columns from the Excel spreadsheet. I'm saying go to row 4 and extract starting from column 3, which is actually the index is 2, up until 7, before 7. And this is what is happening here. We start at column 2, and then we end right before the column 7. And we get all the names of the columns, right? And because row slice works a little bit differently from call values, when we are printing the values, we need to call for the value method. And then it gets the value of that cell. So again, we assign the sheet object. We use the function row slice on line 5 to extract the values from column 2 up to column 7, and then we print those values to the terminal. So please go ahead and execute script number 3. So Python 03, and there you go. You have all the names of the columns from the Excel file. And that is always the case for these Excel files. There is just one minor difference that I'm going to tell you about later on. And here we have the names of the columns. We can use them to build the CSV file to write the names of the columns on the top. Okay, we got the cell values. We got the column values. We got the row values. Now we need to store the row values so that we can use them later. And so open the file number 4 stores row values .py. And there are a few differences here. The beginning is always the same. We import the open workbook, we assign the variable, but now I am creating a dictionary. This dictionary will have the names of the columns and the values of the rows that we want to store. So I'm just creating an empty dictionary here on line 6, and I'm using the same row slice function to get the values that are underneath the name of the columns. So let's get back to the file here. So what I did before was to get the names of the columns on row 5. But what I want is the name, is the values of those columns, right? So starting on column 2 and ending on column 7, I have it's always the case that the values are there. So I use this function here to get the values, right? Right after the plan name. And these values are corresponding to the plan name that is on that line. So I get those values on a list, and I am assigning column names here the way we agreed before inside my dictionary. I'm doing row values, the position 0. Position 0 is this value right here. Position 1 is this one. Position 3, so we skip 1 because this column here it's just the sum of the 2 before it, so we're skipping 1. There is no column name NYSOH in this file, but there are in others. But to keep the consistency of our CSV file, we have to have the same number of columns all the time. So if there is no value on this file, we have to give an empty value for this one. And then we have the total, which is the 5th position, which is this one. And after we do that, we print. So we build a dictionary with the name of the rows, which are here in green, the name of the columns, and we have the values for each column. So let's print that and see what happens. So go to the terminal and do Python 04 and tab for autocompletion. And there I have. There you go. You have the total, the names of the columns, and the respective values. But don't take my word on it. Let's take a look at the actual XLS file and see if it copied the values correctly, right? So we have on total the number 30,616. So let's take a look at the file. And here it is. So total 30,616. Let's take a look at ADC. ADC 21,862, 21,862. So okay, we got the values correctly, but what do we do with this? Now we need to save those values on a CSV file, and then our cleaning is complete, but we have to consolidate all the steps together. So we need to save this dictionary into a CSV file. And how do you create a CSV file in Python? It's really, really easy. This is how you do it. Open file 05 saves CSV. So this file is a repetition of file number 4. You can see here it's basically the same, but it adds 2 important bits. The first bit is the import CSV at the top. This is a Python module that has CSV tools for file creation and manipulation. So you import the CSV at the top, And the other bit that is important, it's right at the end, you see here. So it's a repetition of what we did in the last step. We are creating the dictionary with all of the values. And now we want to save those values on a CSV file. And this last bit here is how you do it. You use the function with from Python. This function guarantees you that when you are creating a file, when you end the code, that file will be closed. It's a major problem when we are manipulating files on an operational system, and if we don't take care to close that file, that could lead to major problems. Other programs and applications running into it, adding information that you didn't authorize. So it's good practice to use code that will certify that your file will be closed in the end. So always, when you are creating files on your own computer, look for the best approach so that your file remains safe. And this Python resolves with the with function. So it's a function that creates the file for you, but when it ends, it certifies that the file will be closed. There is more reference about the with function on the Python documentation if you want. So basically here we're saying open in the folder CSV a file called table.csv, and you're going to open it not in the W, so I'm going to change this. W is the mode. I'm going to change it to A, which is append. We're going to append information to this file, not overwrite information in this file. And treat this file that we just opened as the variable f. And then it starts the block. We're going to assign the tool called dictWriter from CSV on the f file we just created. And the dictWriter needs two parameters: the file we were working with and the keys of the dictionary, which is going to be the header of the file. Then we're going to ask w, which is the object that we just created with the CSV function. We're going to write the header, which is the name of the columns, and then we're going to write the row. So if we go back here at the terminal, we have the names of the columns, right? The name of the columns we write with this function here, write header. The values of the rows here, we write with the function write row, and then we tell where is the dictionary to write the row from the values. And that's basically how you do it. So if you have a big dictionary with all the values that you need for a CSV file, then you can write it row by row or at once. And that's what we're going to do. We're going to get row by row, write to the CSV file, and then get all the results in the end. So let's go to the terminal again. I'm going to run script number 5, Python 05, and I'm going to execute it. Nothing happened, which is good, because if something happened, that was a mistake. So let's get back to the Finder here and open the CSV folder, and there it is. There is a table.csv file in here. And if we take a look at it, it has exactly the information that we needed: the name of the columns and the value of the rows. But this is just like a concept. This is not the CSV file that we're looking for, because we have to automate the extractions on all of the rows and then all of the files. And to do that, we need to first get the date and then get the files in the directory. So let me show you how first we're going to get the date, because this file here, it doesn't have the columns month and year, which is a problem, because if we don't know which month we're talking about, then our analysis is going to be useless. So let's add 2 columns, but first we need to extract the date information from the file, like I showed you before. And to do that, open the file getDate.py. And this is the file. This file shows one different bit, which is the import RE here at the top. This is the regular expression module for Python. And we're using regular expressions because regular expression is a way that computer languages have to find patterns in text and extract information from it. And it has a series of commands or parameters that makes it really easy for us to identify those patterns and extract the information that we want. Always guarantee that we have the right information that we're looking for if it's following a pattern. So this first bit here is very familiar to us. We're just opening the workbook on the sheet 1. We're getting the value of the date, which is A4, so cell value 30. And now we're going to do a regular expression search to find just the month and just the year, right? If you take a look here, this is the cell that we are working with, okay? And this cell has this value, NYS, January 2013. And this is going to be the case for all of the files. So the pattern here is it always starts with NYS, it always has the name of the month, and it always ends with the year, with digits. And we can use regular expression to extract a word that comes after NYS and digits that come after this word. And that's what we're doing here. To do that, we use the match function from the regular expression module. And this is how you do it. This is actually the regular expression query. And I'm going to explain it bit by bit. Let me open up a website here just to explain how this is going to work. So this is the string that we're trying to extract information from, right? And we're going to put the regular expression here that we want to extract. So the first bit is this one. What I'm saying here is I want you to find NYS, and I'm using the brackets to say after NYS, I want you to capture if there is a space or a comma. It doesn't matter. Either a space or a comma, and the plus sign signals that any number of characters after that. So look that the blue part is highlighted, which means my regular expression captured the first part. It found the first part. Now I'm going to add the second bit, which is in parentheses. Parentheses in regular expression means that you're going to capture. This is the information that you want. So you're searching for a string, but you only want the information that is in parentheses. And this is the first information that we want. That's why it's in green, because it's in parentheses. And we're using a regular expression command, the inverted slash and W and plus to mean that we want a word with any number of characters after the NYS. And that's why it captures the January, because it's a word with any number of characters after NYS, comma, and space. And then the second bit here I'm going to add is that after the word month, I want it to capture either a space or a comma. So I put in brackets, either a space or a comma. And even after that, I want it to capture the year. That's why I put it in parentheses. I want it to be digits, any number of digits, after the space or the comma. And as you can see, there are two parentheses in this capture. And if you look down there on match, I have one match, which is the month, and I have the second match, which is the year. And I can get those values and store in my dictionary for the columns month and year. Okay? And that's what I'm doing with Python. I do this search here on the string date, which is, I just save it here from the cell value. And I use the groups function to do the same thing that happened here. So it groups, it gives me a list with two items of the two things that I capture. And then I get the values of this list into the dictionary on the columns year and month. Okay? Since I'm going to do this every time I open a file, I think it's good practice to do a function. So this file here, the number 6 that you're looking at, establishes a function to repeat that operation. So it's exactly the same that you're seeing here, but I'm calling this function getDate. It receives the worksheet that we loaded in the beginning of the file. It gets the date from the cell A4. It runs the regular expression search. It stores the dictionary, and then it returns the dictionary. So we just need to say getDate and put the sheet, and then it returns a dictionary with the dates. Because we're doing that in every file, then we're doing through a function. Okay. So we got the date. Now we need the last bit of this part is that we need to get all of the files in the directory, right? So if you look here on the data folder, let me copy this back. Okay, in the data folder, there are all the Excel files that we need to iterate over. But how can we make Python look for those files, right? To interact with your computer, get the names of the files, open and extract information that we want from them, and then go to the next file. To do that, we use a Python module called OS, which is a bunch of tools to Python to interact with the operational system. And there is one really useful function called listdir. So open up file 7 from your step-by-step folder. So file 7, files in a directory. And we're going to import a module called OS. And from that module, we import the function listdir, which is list directory. I'm importing another module here. You don't have to, but I'm importing another module called pprint, which means pretty print, to print information more beautifully in the terminal, more organized. And this helps visualizing it. It's just a different way to print stuff on the screen. So we are creating a list here. And this list shows all of the files in that directory. We're using the listdir function. And the listdir function gets one parameter, which is the path to the files. The path to the files in this case is the folder data. So I just pass on the path to the file, and then it returns a list with all the names of the files. But since there are hidden files in folders that we don't know about, it's good practice to make sure you're getting only the Excel files. So this for loop here makes sure that we are only getting files that end with XLS. And so we are creating a new list where we're going to store only the names of the Excel files. We're going to iterate over the original files list, and we're going to use the function ends with which is a string operation, it looks to the end of the string and then it returns true or false. Does it end with XLS? If it does, then append that file name to the new list that I'm creating. And then in the end, I'll have a list with only Excel files. But there is a cooler way to do that. You see that here we had 1, 2, 3, 4 steps to do that. You can do that with only one line, as in here in line 17, with something that Python calls list comprehension. I'm not going to explain fully what a list comprehension here is. You can take a look at documentation, but it's really cool because you can create lists on the fly based on conditions. So in this example in line 17, I'm just, instead of creating an empty list, I'm creating a list that I want the file name, but for every file naming files, if the file name ends with XLS, and then it creates the list automatically. It's pretty cool. So take a look at list comprehensions. It's very powerful and less processing heavy. So I'm going to execute this file here right now, and I'm going to show both lists, and they will look exactly the same, which is the list of the file names that we need. So it's Python 07 tab, and there you go. This is the list, the first list with the name of the files. You can see here that we have all of them. And this is the same list, but with less steps. It doesn't really matter how you do it. You're saving only microseconds. So okay, guys, let's take a look at how far we've come. We learn how to get the values of a cell. We learn how to get the column names of an Excel file with Python. And also the row of any values on that Excel file. We learn how to store the values of that row, how to save those values to a CSV, how to get a specific date using regular expression, and how to get the files, the name of the files in a directory. Now we have all of the pieces that we need to make one script that will clean all of the files. And this is reflected in the last file, which is the cleaning routine. So before we open the last file, which is the biggest one, I want to come back here to the spreadsheet and show you what we are doing. So my suggestion to this cleaning approach is, imagine that you are the cursor of the Excel spreadsheet. So what we're doing here is, I am going to go through all of the values on the second column. So I'm here at B1. I'm going to go to B2, B3, B4, until I find totals. If I find totals, so there's a condition here. If I find totals, I'm going to store the number, the value immediately to the left, this one, which is the name of the county. And once I do that, I know that I'm taking values from a county, because all of these values here all of those values, they belong to the same county, right? So I have to keep track of which county where I'm in, and when I go to another county, I have to clean that and start the procedure again. And the way to do it is to identify on the second column if we found totals. So we're here, totals. We get the number on the left, and we start getting the numbers right underneath totals. This one, this one, this one. And not only those values, but everything that comes to the right on the columns that we want. And then we do that again. And every time we check, have we found another totals? Because if we have, then we have to get the value on the left and then get these values here and start over again until we hit the empty space here in the end. Here, the empty space. If we find an empty space, it means that we're over in this file. It's finished. Then we need to go to the next file. So we have a list of files. We're going to iterate over these files. Once we are inside the file, we go through the second column looking for the totals. If we find the totals, we store the name of the county and the values underneath it, every time checking if we hit the totals. If we hit the totals, we get the next values. And we do that over and over again. Let's see how that looks like in code. Okay? Let's open file number 8, cleaning routine. All right. This is the cleaning routine. I'm importing here the XLRD and the CSV. I am opening the worksheet. I'm creating a dictionary for the row. And here I'm doing something that I haven't showed you before. I'm creating a flag called header is written, and I'm assigning it to false. And why is that? Because we're going to be saving every row to the CSV file. And if we write the header every time we write the row, then we will have the name of the columns every time. And we need the name of the columns only once. So I'm assigning this header is written to false, and then at the end, when I write the header, I'm going to assign it to truth, and I'm not going to use it anymore. You see. And then I get the values of column number 2 on a list. And for every value on column number 2, if the value is totals, I get the value on the left. Then I keep track of the county. I am in a county. I'm setting the county to true. And I'm setting a counter to 1, because if you look here in the file, once I get the totals, I get the value on the left. But I need to add the number to get the row that is underneath totals, the row that is 2 underneath totals, the row that is 3 underneath totals, so on and so forth. So it's totals is my base cell. So +1, +2, +3, +4. That's why I have a counter here, because I'm going to get the position of the cell that I want, it's totals plus the counter that I'm assigning. And while the counting is true, which means we're getting this block here, because we haven't found any totals, I'm going to get the plan name with the cell value, and then I get this slice after the plan name, and I store it on the dictionary. And I'm doing 2 conditions here. There are files that have the NYSOH column, and if the file has that column, I find that value, and I store the values like this. And if the file doesn't have, the NYSOH is empty, and then I store these files. And then I do counter 1, because then I'm going down the list of the values on the second column. And then in the end, if I find totals again, I set county to false, because I know I'm not in that county again. I'm in a new county. Then when I come back here, it's going to be false, and then it's going to start in a new county. But if I find a value on column 2 that is empty, I break the loop, I get outside of the loop, and then I save the file, because it means that I don't need to do anything else with it. Okay? So let's run this file right here to see if we can store all of the information for one single file. So this is the cleaning routine for only one file, right? for the file that is here, the January 2013. So I'm going to delete this table here, and I'm going to run Python on 08 cleaning routine. And I check the table here. It's super fast, and all of the values are here. So I got the plan names, the counties, the totals. There is no NYSOH on this file, so it's expected that this column is empty for this file specifically, but there are other files with these values, so it's going to be populated. And we have the numbers for all of the enrollments. This is for one file, but we have to do this for every file. And how do we do it? It's pretty easy. We just get this whole block here of code. So this whole block here of code, we have to put it inside a loop of all the files. That's it. So we get this block, and we put it inside a for loop that iterates over the names of the files. And then it's going to repeat over and over again, appending the information to the CSV file. And the result in the end is the file that is on the root. So go back to the PyPerugia 16, and this is the cleaner.py. So this is the final file that will clean all the information for all the files for you. And it has all of the imports. So let's take a look at the file now. Import regular expression, okay, check. Import CSV, check. Import from XLRD, import open workbook, check. From OS, import listdir, check. Here I'm defining first this function to get the date, because I'm going to use it later on the file. So I get the date using this regular expression, and I save the dictionary. I create the empty row, and now since I'm going to be using the data folder all the time, I'm going to assign a variable called basedir, so base directory called data. And I'm going to get the list of the files with the listdir function. And what I do is, to generate the path to the file, I do basedir plus the value on that list. And then I get the full path for the file. I generate the list of file names with only Excel files. I set the header to false. So for file name in the sheets, so I just created here this list with all the Excel files. For every file in that list, I'm going to print a helpful information that I'm parsing the information from that specific file, just for verbose purposes. I'm going to open the worksheet. So we're doing this, we have been doing this all the time. Look at line 4. We have been doing this all the time, but we're always using a specific file, right? We're now using a conjunction of, so we're getting the basedir, and we're adding the file name from the list of files to generate the path. So we open the worksheet, we get the date, we store the date in the dictionary, and then we get the values. So here we start this block here. We get the name of the columns with the values of the column 2. And then for every value in that column, if I find totals, I store the name of the county. I set county to true and the counter to 1. And while county is true, I get the plan names, and I also get the values after the plan names. I store those values according to the strategy that I set. So if there is a column called NYSOH, or if there isn't. I set the counter to 1 because I want to go to the line after that, to the row after that. And if I find another totals, I set counting to false, and then I restart. And if I find an empty space, I break and I go to the next file on this loop here. And then I save the row. And saving the row is, if header is written is false, because I set it to false here, then I write the first line of the CSV file with the right header, and then I set it to true, because then it's not going to do that anymore at the execution of the program. It does it only once. And then I only do write row, and I do write row all over the files. So let's see how the cleaner.py executes to generate the final CSV file with all the information that we need. I'm going to clear, and I'm going to do cleaner. Oh, actually, Python. I have to go back one directory. Yes, and then I do Python cleaner.py, and then it goes over all the files and generates the table with all the information that I need. Look now that I have month and year here, and it has everything from all the files. Now I can create categories, I can create pivot tables, I can see which companies are getting more enrollments, in which counties, if there is a month, a specific month that there was a particular growth, what was the year that was more significant. This CSV file is much more useful to me than all of the Excel files that we had before. So just retracing our steps, going back to the step by step. We got a cell value, we got the column values, the row values, we store the row values, we create the CSV, we get the date, we get the files in the dictionary, and then we simulate what the cursor would do. So it goes down, saves to the left, goes down, new county, saves to the left, get the numbers here until it finds a space, go to the next file. So the most important thing that I wanted you to come out of this session is not necessarily how to do this exercise. It's how can you, in your career, design your own cleaning strategies. How can you approach problems like this, which are many, right? We can find many problems like this. How can you approach problems like this and design your own strategy and use Python to help you? Because once you do it, every time the agency or the government or the company, they release a new file, you just have to run the script once. And it adds to your database. So think about the columns, think about the repetitions, think about the patterns, and think how you can break those tasks down into simple files first, so you can test the extraction, you can test on a single row or on a single file, and then you do for every file. And with that, I finish my presentation. I'll be taking questions if you have any, but if not, thank you very much for your patience and participation.
Excuse me.
Yep.
Is there a site or a tutorial where I can approach, where I can learn the Python language from the beginning? Because I'm absolutely a beginner, so your workshop is very interesting, but sometimes I can catch everything because I don't have the basis of the Python languages. So I think it could be interesting a tutorial, a site where I can experiment, where I can approach to this language? Thank you.
That's a very good question. Thank you very much. There are a number of resources online for free so that you can start learning how to program Python or any other language. I suggest for those who just want to experiment, just to try to see if they like it, a website called Code Academy. Code Academy it's a website with a lot of programming languages and a lot of easy to do exercises so that you can experiment for free. But it will not get you to a high level, right? It gets you just the first tastes. If you really want to be serious about programming, I suggest you taking a look at the edX courses. edX is an online learning platform from the MIT and Harvard. They have a course called Introduction to Computer Science and Programming Using Python. This course is free. It takes about 9 weeks. It's very, very, very difficult, but it's the best out there. If you really take steps into concluding this course, you will become a developer. It's not gonna be a course in 9 weeks that will take you to be a fully developed developer, but this introduces you to the basics with very good exercises, very good classes, very good reading materials. So if I have to suggest one course about learning Python, and not only learning Python, because this is not the objective of this course, to do programming is not about learning how to code, but learning how to transform real-world problems into problems that the computer can break and understand. And this is what this course is about. It teaches you to change your mindset of how to approach problems, turn these problems into algorithms, and then write code so that a computer can solve it. So it's an introduction to computer science and programming using Python. So you will learn Python along the way, but actually what you're learning is how to approach problems like we saw today with a mind that you can get the computer to solve it for you. So it's not really like I don't think people should aim at learning how to program. People should aim at learning how computers work and how to approach problems in an algorithmic way. And then you can solve those problems using any language that you want. It happens that Python is an easy one and very well supported. So edX, Introduction to Computer Science and Programming Using Python. It's free. It's just 9 weeks. It's just that it's very difficult. But the interface is really good. The videos are awesome. The exercises are outstanding. And the system, the mechanism that they use to correct the exercises and the tests is really good as well. So yeah, thank you for your question. Yes? Just.
Thanks. How many hours would you say you spent each week on this? How many hours would you say you spent each week on those 9 weeks?
Okay, so the course says that you would have to spend 15 hours every week, so 3 hours a day, right? Which doesn't sound much, but when I took it, it was like 12 hours a day. So it depends, it really depends on your background. It really depends on how deep you want to go to the course. So they say 15 hours, maybe it's 15 hours for regular students at the MIT, because this is an MIT course. But for me, it was much more than 15 hours a week. And you can do it in your own pace as well. They give you extra time. You have access to the material later, so you can always use some more time to do it. It's nice to do on real time because you have contact with other students, but you can definitely use more of your time. So 3 hours a day, 4 hours a day per week. So, or maybe your whole Sunday or your whole Saturday, right? I mean, it's worth it. It's only 9 weeks, right? It will change. Thank you. Yeah?
So much time does it cost to research these Excel sheets, come up with this solution, and then build it for an experienced user like you?
Okay, so he asked how much time it would take to come up with a solution for spreadsheets like this and design a strategy, right?
Yeah, and most of all, because there's one column that's empty in a few sheets, so you have to open each sheet before you can kind of.
Yeah, that's a good question. So how do you make sure that you're getting the values from all of the sheets and they are always in the same position? So how do you do that? You, instead of opening every file and checking yourself, you can write a script that extracts the information from that exact location, and you count the number of times that that information appears. And then you compare the number of times that you extracted with the number of files that exist, and if they match, then you have a solid proof that all of the values are there. So there are automatic ways to check of the information. If you have hundreds of thousands of files, for example, you can write a script just to check the information on A4. I want to make sure that all of the A4s on these files, they have the date, but I don't want to open every single file. So I write the script to make a list of those values, and then I count the number of items on that list. And if it matches the number of files, then yes. So you can do that on, very quickly with programming as well. Thank you.
My first question was how much time?
It depends, right? So if you're just starting, then it will take longer, right? Maybe a whole afternoon, maybe one day. But as you get used to it, it takes less and less time for you to come up with these strategies. You take a look at it and then you test, and maybe it's going to be a couple of hours. But it varies on which stage you are in your developing career. Yeah. Yes, please.
Can you apply Python also to Google Sheets by any chance?
There is.
I know they're JavaScript based, but I was wondering if you could apply the same coding.
I'm not sure because, like you said, Google Sheets has a script-based language that is based on JavaScript that you can code on the back end. But the Google Sheets service has an API. You don't have to work with the script editor inside the spreadsheet. You can access the API from the outside. And since it's an API, it's language agnostic. You could use Python to automate this API to access Google Sheet values. So yes.
So they should work.
Yes.
Okay, perfect.
Yes.
Thank you very
Just
much.
take a look at the Google Sheets API documentation. You can go here, Google Sheets API documentation. Here, Sheets API. Okay. Oh, it's not. Yeah. Sorry, it's not being projected. But if you, yeah. So if you type on Google Sheets API documentation, you see everything that you can do with Google Sheets, and you can use Python.
Thank you.
Thank you.
Thank you.
I guess this is it. Thank you, guys. Oh no, one more question. Okay.
I'm a computer science student, and we're learning C++. So I'd like to know, what are the advantages of using Python instead of other languages, for example?
Okay, that's a great question. Thank you. C++ and Python. Why would you use Python instead of C++? There is one big difference between C++ and Python, which is C++ is a language that you compile, right? And Python is a language that you script. So this is a big difference because when you have to compile stuff, it takes some time to compile, right? And it's different. When you are doing scripting, the interpreter of the language interprets every command in real time. For languages like C++, you have to interpret all of the commands beforehand, and then it generates a file, and then you use that file. There are different applications for this, but scripting languages like Python, PHP, Ruby, JavaScript, Those languages are very good for prototyping and coding products really fast. So if you wanna test stuff and have like an interpreter, real-time interpreter to test stuff, I would recommend using a scripting language. But it's also true that today they are designing ways to get scripting languages to generate applications as well, to behave much like C++ and C and assembly and other languages behave. But in the end, just use the language that's more appropriate for you. In this case, for web applications and for scripting tasks really quickly, I wouldn't say that C++ it's very useful, because you have to compile, right? And why would you compile something that you can execute really quickly from the terminal? But you could definitely write a C++ program to do that cleaning routine that we did. It's just that it would be inconvenient in this case. But maybe there are more people here in the room that can also add to that answer. But for me, it would be that. Thank you. Okay, guys, thank you so much. Enjoy Perugia.